Today we're talking about the relationship between rational and irrational numbers. A rational number can be written as a fraction. This decimal form can be written in either terminating or repeating as a decimal. So, a rational number that can be written as a fraction are these numbers. Whole numbers and integers all fall into this category. So, if you look at these are all rational. Anything whole, 0 all the way positive whole numbers, and their negative counterparts, the integers, as well as any number that we could write as a fraction. For example, 1/10 could be written like so. Irrational numbers, on the other hand, cannot be written as a fraction. Their decimal form goes on and on forever. Pi, the ratio of a circle's circumference to its diameter, is an irrational number. Square roots of imperfect squares and certain square roots are also irrational because they go on forever, which means they don't terminate or repeat like our rational friends. So, the first step in figuring out is to write each fraction or mixed number as a decimal. If it's already written as a fraction, we know that it's rational. But the second step is to then make it into a decimal to figure out if it's terminating or repeating. For example, 5/8 is really 5 divided by 8. Okay, when we look at any fraction, it's really a division problem. So when we look here, we are taking 5 divided by 8. We know 8 goes into 5 0 times. Add your decimal. I can put as many zeros behind that decimal point as I want because it's not changing 5's value. So when we divide then by 50, we get 6. 6 times 8 is 48. Subtract 50 minus 48 and get 20. Or get 2. Bring down my 0 to get 20. Sorry about that. Divide by 8 and you get 2. 8 times 2 is 16. Subtract 2 and get 4. Bring down our other 0 to get 40. And 8 goes into 40 5 times evenly. So this number stops, which means it terminates. Okay, the next one, -1 2/3 can be written like this, -5 over 3. So you can divide 5 by 3 and add the negative sign, or we can also divide 2 by 3 and just make sure that when we write it, we put the -1 in our decimal. So if you want to divide 5 by 3, you can look over here, but I'm going to show you how to divide by the 2. I find this to be easier to just worry about this fraction. So 3 does not go into 2, so I have my decimal point and my 0. 3 goes into 20 6 times. 6 times 3 is 18, and as you see, it's going to keep repeating. So this is -1 and 6/10 repeating, and this is a repeating decimal. All right, you try these. I'll be back in just a second to show you the answers. Okay, make sure that you've shown all your work. Go ahead and check this with a red pen. Here are my answers. If you got 75 hundredths for 3/4, you did good. For B, make sure that you have the negative sign and make sure that you have the bar notation. Bar notation is the repeating sign. For 4 and 13/25, you would have gotten 4 and 52 hundredths. And for 3 and 1/11, you would have gotten 3 and 9 hundredths repeating. So the 0 and the 9 are both repeating. Make sure you have the bar notation over both of them. All right, what if they want us to write it as a fraction to prove that it's rational? Well, we can write 45 hundredths as a fraction. When you say the number, you hear its last name, as I like to call it. So that's 45 hundredths, which means you're going to put the 45 over 100 and simplify. What if it's a repeating decimal? To do that, it's a little bit more complicated. The first step that we're going to take is we are going to pretend like this equals some number. We're going to say the number n is what it's going to equal. All right, remember we can place any variable as a number. So what we're saying is this equals n. We're going to then multiply it by 10. Basically, what we're trying to do is we're trying to get rid of the repeating decimal. This is a little bit confusing, so make sure you're watching me all the way. So when I multiply it by 10, I get 10n. You got to do it to both sides. Whatever you do to one side, you do to the other. So I'm multiplying n by 10, which means I have 10 n's. I'm going to multiply 10 by my repeating 5, and I get 5 and the 5 repeating. So now I'm going to remove my original. This removes all of the repeating 5s, which means I'm just going to be left with 5. Now when I do this, I'm also removing an n. When I take this whole thing away, I'm taking the n away and the repeating 5s away. So I'm left with 9n equals 5. So now the question is, what number times 9 gives you 5? So let's divide. When I divide 5 by 9, I get 5/9. So I have put my repeating decimal in a fractional form. Go ahead and check it with your calculator. Divide 5 by 9, and I guarantee you're going to get 5 repeating. Okay, let's try another one. Go ahead and see if you can do this one. Write 2 and 18/100 repeating as a mixed number in simplest form. If you need to, go back and look at this example. Remember, you are following this algorithm, so make sure you follow each step individually. Okay, so here you go. Try this, and when you're ready, grab your red pen because I will show you how I did it. Okay, so my first step, I'm assigning a variable to the value 2 and 18/100 repeating. So I always just assign n because it's a number. That's what I'm thinking. So n equals my 2 and 18/100 repeating. Then I'm going to multiply it by, not this time 10, but instead hundredths. Okay, so I'm going to multiply it by 100 because we are using hundredths. So I want to get rid of this 1 and the 8. So when I multiply by 100, notice that I get 218 and 18/100 repeating. So now I'm taking away this whole thing. Okay, so I'm taking away the n, which gives me 99n. Then I'm taking away the 2 and 18/100, which gives me 216. The 1 cancels out, the 8 cancels out, the 1 cancels out, and it goes on and on forever. 8 minus 2 is 6, so that's where I got the 16. Now, my question is, what number times 99 gives me 216? So I can divide by 99 on both sides, and I get 216/99. Or if I simplify that from an improper fraction to a mixed number, I get 2 and 2/11. The decimal 2 and 18/100 can be written as 2 and 2/11. Remember, I want you to try not to use a calculator. That way, you know that you're doing it right. Okay, so let's talk rational and irrational a little bit more. Tell whether the number is rational or irrational and explain. -7/8, the square root of 5, 25/100, and 1/9. I want you to go ahead and try this real quick to see what you think. Okay, I'll be back in just a second to show you the answers. Okay, so if you look at each one of these, this guy's already written as a fraction, so we know he's rational. However, if we look at his decimal form, he equals 875 thousandths, so he terminates. If we look at the square root of 5, he is an irrational number. So when we write him as a decimal, he's going to go on and on forever. 25/100 can be written as a fraction, so we know he's rational. And since that number is ending, it terminates. It stops after the 5. 1/9 is a repeating 1. So this is a repeating decimal. It's already written as a fraction, so we clearly can see that he's rational. Now let's try to order these from least to greatest. Well, we know he's our least because he's negative. So he's negative 8/100ths. So if we look here, we're going to plot a point here and write negative 7/8. If we look at our irrational number, the square root of 5, he's almost to 2 1/4. So we're going to plot him right about here and write square root of 5. 25/100ths is 1/4, so we're going to plot him right about here. And 1/9 is actually a little bit smaller than the 25/100ths, so we're making another dot there. I'm going to draw a little arrow so we know that that is my 1/9. All right, go ahead and you try this one. I'll be back in just a second to show you the answers. Okay, grab that red pen. Here we go. Okay, here's my answers. I don't know if you saw that dot before, but I think somehow it magically disappeared, but it's back now. So this number, just in case you were like, whoa, that's a really big number, I don't even know where it goes, it's actually supposed to be a decimal. So go ahead and check your work, and that's all I have for you today. See you next time.